Hello and welcome to an automation video where today I'm just going to go over some common mistakes people tend to make when building engines, and yeah, just sort of explaining why these things that I often see people doing are bad, and basically how to get around them and stop doing them. First of all, a common thing I see people doing is not using all their octane. If you see on the stats, there's a little gas pump symbol. Usually it'll be in RON if you're sane, or if you're insane you're using AKI. Yeah, both these, the stand on the left there is the one you want to pay attention to. As you can see, mine is 89.1 and my fuel that I'm using is Premium 95. Now that means that this number can be 95 or as close to as possible. So yeah, basically I just want to keep upping compression until I get as close to as possible. If you go over 95 you begin to knock. So yeah, you want to get as close to that as possible, adjust ignition timing and fuel mixture and so on to try and get as close to as possible without going over. Next thing I see a lot of new players do is complain that they can't lower, say, like fuel mixture, increase ignition timing, or lower cam profile because their engine starts to knock. And so, for example, going for a much more eco tune here, 14.5 from 13.8, yeah, my engine begins to knock because I'm putting less fuel in. What people don't seem to realise is that compression shouldn't control your engine build. Always be willing to change compression. Usually the way you want to go about it is set cam profile first, depending on the engine. So obviously take into account like what kind of engine it is. For a more normal car you want to set cam profile from anywhere between 30 and 40 usually. Something more sporty about 50 to 60, and then hypercars and track cars towards the upper end. Obviously it's not total rules, but yeah, I tend to follow that. Then go to fuel mixture, where usually you want it to be 15, unless you're trying to build something a bit sporty. And then usually just adjust ignition timing and compression until you have something to work with. Another thing I see people using is internals that are way too expensive for what you really need. For example, billet steel, lightweight titanium and lightweight forged are all really expensive and really, well, like really strong materials. They can take high RPMs and lots of torque, but you really don't need it. If I drop back down to forged and even a cast iron crank, you can see on the right here the RPM limits, and I'm within them. In fact, just within this. If I go any higher, then I start to get issues. So yeah, always pay attention to your limit and try and run the bare minimum you need to. If you can afford to, even take a bit of quality off. In this case, I can take a small bit of quality off. Yeah, I only lose 0.1 for not a small gain actually. 0.2 production units isn't bad, especially if this was a mass-produced car. So just something to consider when doing it. Other things you can do too, if you just slightly under, is lower stroke slightly. You know, I want to rev it to 8.3, but I can't for whatever reason, like here. If I just lower stroke until I get no reliability penalty here, and yeah, it's fine. Only a tiny bit of capacity lost, and now I have no reliability issues. Another big problem I see is people cutting power off at redline. This is a terrible thing to do. Think of it this way: when you're accelerating a car and you're reaching your top speed or whatever in that gear, you can never actually get to that top power, mainly because you'll either just bounce off the red line and just be stuck at your speed, or you'll just shift earlier. It's just power that you can never actually use. So yeah, always try and open that up. Usually try to have at least 200 RPM over, but having more. On the flip side though, you don't want to go too high because otherwise you get valve float, also significant drop off, which means that again it's just power that you can't use because it's just so low. So usually you want to have a bit over, but not sort of insane amounts. Just look to see how far you drop off. Like here, there's only a bit of drop off towards the end. Another thing is using quality spam. Now I'm not talking about just having insane, you know, plus 15 on every component, just track monsters, because I get that, everyone wants to build them. It's when people put like, say like, plus 8 here, and just like, you know, just put like plus 10 here, because they don't realise that it adds up, and now it takes 144 months to build, or 12 years to build this engine, or to engineer it. Like a bit of quality, that's fine if you're just upping it slightly. I get that, but it's when you're going absolutely insane. Like plus 8 is really not necessary for an engine like this. Another thing I sometimes see is people using leaded fuel types in later years. After 1978, I think it is, in Fruinia, leaded fuel gets banned, and then in other places it begins to get banned as well. So, I mean, usually try and switch to unleaded fuel by the 70s, or like during the 70s. You want to usually try and make that switch, even for realism reasons, as that's when most of the world started, well, mainly America, started using unleaded fuels. But yeah, just picking a fuel type that's appropriate for the year. Like this is 2012, you definitely wouldn't see the leaded fuels anywhere in the world. Another thing I see sometimes is people using mixed materials or just strange materials for the time period. Like for example, having aluminium blocks in 1960s for like a small commuter car, where reliability does matter. In the early years, aluminium is very unreliable, and by 1996, Alcyon locks, which is like aluminium but better, lower production units. In fact, if we just hold that and then switch, you can see the difference here. It's lower production units and engineering time, but only slightly more expensive and also a bit lighter. So yeah, it's definitely a better material to go for if you can afford it. Also, mixing materials is never a good thing. One exception is cast iron with aluminium during sort of the 70s, 80s and 90s as you're making that transition. That's okay because, you know, you want to lighten the engine but get a bit more reliability. But afterwards, especially considering there's not too much of a difference in reliability really between them, like that's a fairly small difference between cast iron and just running LC, or obviously using a magnesium block and then an LC head. Magnesium though you'd only really want for high-end race cars. Finally, I tend to see people making some weird choices in terms of turbo tuning. Let's just stop this from knocking. For example, not really paying attention to what's actually happening here. Now here your flow bench is your best friend. For example, some people have intercoolers which are restricting power. Let's just lower boost a bit so we don't get any issues knocking. Yeah, you never want an intercooler restricting power ever. Another thing you want as a basic setup is start off like this: minimum turbine and compressor, maximum AR. You also never want to run journal bearings where possible. Always go with a ball bearing. As you can see, there's barely any difference in cost, and yeah, much less turbo lag. This may change in an update that's coming that changes engineering time, but for the time being at least this is a superior setup. Anyway, after you've started up your turbo setup like this, basically you want your turbine to be usually around 0.82. Always lower turbine if you can, but if your turbine is at minimum, lower AR. Otherwise, AR should be at 1.4 if turbine isn't at minimum. Then run a bigger compressor, basically. You want a considerable gap between it. Usually I find a mid 0.9 compressor works. So for example, both of these places work. 0.93, 0.96, both are fairly reasonable, but if I need to try and improve spooling a bit, as you can see, I can lower AR a bit. Turbine's already at minimum, and there's not a power drop at all. And I can also run slightly smaller intercooler if I want, but yeah, increasing the intercooler size is basically just free power. There's very little about it that actually gives you problems, so yeah, usually just good to do that. And yeah, here you can see other things, intakes, where if that's restricting you, change your configuration or even fuel system. Valves, if that's restricting you, run a higher bore, which can also help with intake, but yeah, run a higher bore or add more valves. And then exhaust, and exhaust and headers actually, which, well, that just is self-explanatory, increase your exhaust size. Speaking of exhausts, actually, smaller exhausts do help with efficiency. Not so much on turbo engines, although I am knocking there. But yeah, on naturally aspirated engines, strangling your engine slightly can improve fuel economy. Anyway, hopefully some of these was useful and wasn't too difficult to understand. Happy to answer any questions in the comments. But yeah, thank you for watching. Goodbye.